Hello, guys. Welcome to Ramtel Solutions. Welcome to your grade 11 physical sciences. On our redox reactions today, we are looking at oxidation numbers. And of course, this is the second video. So without any waste of time, let's get into it. So when we talk of redox or oxidation numbers, rather, we're talking of the charge that an atom would have if it was in a compound of ions. Okay, this is the charge that that atom would have if it was in a compound of ions, and we are going to look at that shortly. But now, to give more meaning to this definition, we are basically saying that the oxidation number of an element in a compound, it is basically the charge that its atoms would possess if that compound were an ion. Okay, all right. So now oxidation numbers, it seems that it is easy to assign them because we we assign. Remember, we were saying that it is basically the charge the atoms would possess if the compound were ions. So from this, we somehow would think that it's a bit easy because we can assign them according to how we assign charges. Remember, in your periodic table, you assign charges group 1, you will have +1, group 2, +2, group 13, +3, group 14, +4, -4, group 15, -3, just like that, right? So we would think that it's easy to assign them like that. However, there are rules which will assist us in assigning oxidation numbers to create that consistency and stability of a molecule, all right, or a compound. Okay, now we are going to explore these rules. Now, let's see what these rules are. Guys, you don't have to cram these rules, but of course, with practice, you will get them. Okay, but otherwise, we are not shifting much from that. We can assign them in the same way as we assign charges according to groups that elements belong to. But there are rules. So there are some rules that you must take into account or into consideration. So let's look at the rules. So the rules are: 1, oxidation number of an atom in elemental state is 0. Let's say, for example, I will take hydrogen gas. Okay, normally we get it as a gas, right? It's hydrogen gas. What would be its oxidation number? It'll be 2H equals 0. Therefore, what is its oxidation number? It's 0. Do you guys see that? Oxidation number of carbon, it'll be 0. Of oxygen, it'll be oxygen gas. So the oxidation number of that oxygen atom will be 0. Right? So yes, oxidation number of an atom in elemental state is 0. Happy? Perfect. Oxidation number of a monatomic ion is equal to the charge. For example, let's say we have bromide. Right? Remember, when it's an element, we call it bromine. When it's an ion, we call it bromide. So it's a bromide ion. So its oxidation number would be -1. Now let me read the second rule. Oxidation number of a monatomic ion is equal to the charge. The charge here is -1. As you can see, it's -1. So oxidation number of a monatomic ion is equal to the charge. Happy? Good. Now, oxidation numbers for non-metals are assigned as follows. Guys, from grade 10, you know what are non-metals, where they are, and so on, right? Now, let's look at hydrogen. For hydrogen, oxidation number of hydrogen when combined with non-metals, okay? Oxidation number of hydrogen when combined with non-metals will always be +1. You don't have to find it. You must know. This is why we say there are rules. Oxidation number of hydrogen when combined with non-metals will be +1. Okay. Now, oxidation number of hydrogen when bonded with metals, it'll be -1. This is something that you must know. Okay. This is something that you must know. Now, for oxygen, it is -2 in almost all compounds except peroxide. So with peroxide, this is when your oxygen is like this, isn't it? This is when your oxygen is like this. This is peroxide. Okay. This is peroxide. And then it is negative half when you have superoxides. So superoxides, it will be when it is like this. Okay, when it is like this, this will be the oxidation number of oxygen. Now let's look at the halogens. For halogens, it is always negative. For fluorine, it's always -1. Okay, for fluorine, it's always -1. Okay, repeat, for fluorine, it's always -1. Okay, now, and then you then say, what about other halogens? Other halogens will always be -1 except when combined with oxygen or other halogens. Okay, except when combined with oxygen or other halogens. For example, if you say, let's say fluorine gas, F2, its oxidation number will not be -1, but rather 0, if you get my point. Right? So remember that halogens, their oxidation number will be -1, right? Will be -1 except when combined with with oxygen or other halogens. Okay, now let's give you the fourth. This one, the sum of oxidation numbers for all atoms in a molecule. I want you to highlight this. Sum of all atoms in a molecule or a polyatomic ion equals the charge on the molecule or ion. Okay, equals the charge on the molecule or ion. Okay, happy? Perfect. Now, let's try examples. So we will say, I write down the oxidation numbers. So we'll say, I write down the oxidation numbers. Write down the oxidation numbers. Ooh, what's happening? Okay, write down the oxidation numbers of the following. Each atom, if none is underlined. If none is underlined. Okay, each atom if none is underlined. Okay, now we're gonna say 1, we're gonna look at H2S. 2, we're gonna look at SO3 2 minus, and then number 3 we're gonna look at Na2SO4. Number 4 we're gonna look at H2O2. Number 5 we're gonna look at, let me see, we're gonna look at H2O. Number 6 we're gonna look at KNO3. I'm underlining nitrogen. Number 7 we're looking at AlH3, underlining aluminium. Number 8 we're gonna look at NH4 plus. Which one should I underline? I don't need this. I don't need this. Let me try this one here. Let me try 2PO4 minus. I'm going to underline P, phosphate. Right? Okay. Now let's go. Our solutions. I want to show you, I have pasted the periodic table here. Okay, I have pasted the periodic table. Let me zoom it a bit. Perhaps fill the whole page. Okay, perhaps fill the whole page. Let's see. Okay, I'm always going to come back to refer to it. Number one, we were looking at H2S. So let's look at sulfur. Okay, it's in group 16, right? Group 16. Okay, it's in group 16. That's cool. Group 16, normally it would have an oxidation number of -2, right? Normally it would have an oxidation number of -2. And then what is this? Hydrogen. Let's look at the rules. Hydrogen, when combined with non-metals, right? When combined with non-metals, it is. When combined with non-metals, it'll be +1, isn't it? So what we're going to do, these are the rules. So for hydrogens, oxidation number, let's call it, for hydrogen, oxidation number is, +1. This is the rule, guys. So we don't waste our time. This is the rule. Remember, hydrogen, when combined with non-metals, it's +1. Okay, it's +1. Happy? It's +1. I know it's tempting to say, okay, let's try this. 2x plus, okay, I like calling it like this. 2h, I like saying 2h plus s equals 0. As you can see, the charge here is 0. So when you look at it, it'll be 2h. What is the oxidation number of this guy? It's -2, right? And then 2h equals +2. Therefore, h equals +1. It's tempting to say this, right? And this is where most of the students rush to whenever you calculate oxidation numbers. But it's not really supposed to be like that. Okay? Sometimes remember the rules. But of course, when you're writing your exams, you don't remember the rules, right? Or you don't have the list of the rules written. Now, let's look for the sulfur. For the sulfur, let's look at the hydrogen. The hydrogen is bonded with a non-metal, right? So what are we going to say? We're going to say, since the hydrogen is bonded with a non-metal, let's just say 2H plus sulfur equals 0. So it'll be 2 +1 plus S. I know there are those that say whichever that you are calculating as a, to find its oxidation number, call it X. It's okay, guys. You can do that. Equals 0. So what is this? S equals -2. Indeed, the oxidation number of this guy is -2. Now, to show that indeed it's -2, it's like this. This is +1. Oxidation number of hydrogen is +1. 1 times 2 is +2. Oxidation number of sulfur is -2. Now, +2 minus 2 becomes 0. Indeed, the sum of the oxidation number will be 0. Right? As you can see, the sum of the oxidation number will be 0. The charge is 0. Okay, perfect. Number 2, we had this guy here, 2 minus. So let's look at this guy here. I'm going to stick to calling it whatever that we are calculating for. I'm going to call it X, okay? So we're looking for sulfur, isn't it? We're looking for sulfur. Let's call it X. So what we're doing, normally we say X plus 3, let me say oxygen, is equal to, what is the charge of this ion? It's -2. Remember the rule. The rule said sum of oxidation numbers for all atoms in a molecule or a polyatomic ion equals the charge on the molecule or ion. Okay, and this is what we did as well for the first question. So what is this? Oxidation number of oxygen is -2. Now remember the rule. Oxidation number for oxygen, when oxygen in most compounds is -2. In peroxide is -1. Let's go. So here is it, -2. So what does it mean? X equals, right? X equals +4, isn't it? X equals +4, right? Now let's check for oxygen. For oxygen, oxidation number, guys. For oxygen, oxidation number, because this is not a peroxide or superoxide, it is simply -2. Okay, it is simply -2. Now, if you want to be sure, check this out. Sulfur, its oxidation number is +4. Oxygen, its oxidation number is 3. So 3 times -2, what is it? This becomes -2. Isn't this your -2? It is. So this means our oxidation numbers are Okay, it means our oxidation numbers are correct. Okay, remember the sum of the oxidation numbers must be equal to what? The charge, right? It must be equal to the charge. So we are now also incorporating rule 4. Okay, perfect. Number 3, we are looking at Na2SO4, Na2SA4. So this one, guys, it's very, very, very tricky. It's very, very tricky. I want to show you something about this guy. If you look at this guy, it's like he's made up of Na plus and SA42 minus, isn't it? And when you look at them, if you were to react them, it's like it'll give you this. Can you see that? It'll give you this. Now, when you look for oxidation number of the sodium, what is it? It is equal to positive 1. All right? It is equal to positive 1. Can you guys see that? It is equal to positive 1. Are you guys happy with that? It is equal to positive 1. All right. Now, check this one. Let's now look for the sulfur. Let's now look for the sulfur. For the sulfur, it will be X plus 4. Oxidation number of oxygen is -2 because it is here. It is not with a it is not a superoxide. Peroxide or superoxide. Right? So it is -2, and this must be equal to -2. So what is this? X equals positive 6. Okay. Now let's check for oxygen. Come on, for oxygen. This is not with a peroxide or superoxide, so it'll simply be -2. Now let's check if the sum of the oxidation numbers will be 0. Remember, this must be 0. In other words, I'm trying to say 2Na plus sulfur plus 4 oxygen must be 0. Okay, now let's check. This is positive 2 times positive 1. Okay, 2 times positive 1 plus it's 6 plus 4 into -2. Right? 4 into -2. What are we getting? We are indeed getting 0. So it means oxidation numbers are balanced. Right? It means oxidation numbers are balanced. Guys, I want to show you something with this one, which might be tempting. Some of you will try to do this. You will say, this is too, let's see. I'm not sure if it'll work, but I'm going to show you something. Some of you will say this. You will say, no, but for oxidation numbers, we must say 2 sodium plus sulfur plus, what is this? Plus 4 oxygens is equal to 0. So we're looking for the oxidation number of sodium. You will be tempted to say this, X, and sulfur, you are in group 6, so in -2, and then oxygen, you are in group 6, you are in -2, right? You will be tempted to say this. Now check this out. This looks like -2 minus 8, right? So 2x equals positive 10. Playing that x equals positive 5. You will be tempted to say this is your answer, all right? You will be tempted to say this is your answer. And guys, it's actually, you will be tempted to say it's positive 5. But when you look at it and then you say, okay, doing the very same thing that you do with all of them, you will try to find the oxidation number of, what is this? You will try to find the oxidation number of sulfur using the very same procedure. It'll be giving you maybe 2, it'll be 2 plus 8, which is, it's going to come back to give you this, right? It's going to come back to give you this. And when you look at it, you're like, this is not balancing. So I'm going to show you. So if you are going to say, what is this? Let's say, okay, for sodium plus sulfur is unknown plus oxygens, what does it give you? Equals 0. What does it give you? This will give you positive 6, right? Now let's look for oxygen. Using the very same strategy, you will say it is X, not X, man. You will say it is 2 times positive 1 plus -2 plus 4 times oxygen is unknown. And what is this? This will say to you X equals 0. Do you see this? It'll say to you, you are saying oxidation number of oxygen is 0. And when you add them, you will be getting 2 times positive 5 plus 6 plus 4 times 0. Look at this. It is not working. Can you see that? Now, this is where I am saying, be careful. Oxidation numbers are not really straightforward to calculate. This is why you need the rules. Okay, this is why you need the rules. Now, remember, this is so wrong. Okay, this is so wrong. Okay, so pay attention that you don't do these mistakes. It's important that you remember the rules. Okay, it's important that you remember the rules. Okay, perfect. All right, number 4, we are looking at hydrogen peroxide. Now with this one, I didn't underline any. What is the, remember, let's check the rules of hydrogen. The rules for hydrogen, it is +1 when combined with non-metals, and oxygen is a non-metal. If you are not aware, let's see, here is it, right? What are they? They are non-metals, isn't it? They are non-metals, right? Or do you want us to call them transition metals? They are not. They are non-metals, isn't it? Perfect. They are non-metals. Remember, you can refer to these colors here. Right? You can refer to these colors here. All right? As you can see, alkali earth metals are these ones here. And then alkaline earth metals are these ones here. And then transition earth metals are these ones here. Right? And then post-transition metals, as you can see, are these ones here. And then you then are going to be looking at metalloids. Look at this yellow. Here are they, right? And then you look at reactive non-metals. Where are they? Are these ones here. Noble gases are these ones here. Lanthanides are these ones here. Actinides are these ones here. And non-metals are these ones here. You see that? Perfect. Now, for this particular question, hydrogen, remember, when it's reacted with non-metals, it's +1. Don't waste your time. Okay, you don't waste your time. It is +1. And then oxygen, this is a peroxide. What is it? It is -1. Okay, it is a peroxide. It is -1. I know for this one, that method that we like saying 2 + 1 + 2x is equal to 0. What is this? 2x equals -2. X equals -1. Can you see that? We were able to prove that, isn't it? Now, let's check. This is +1, this is -1. So it's 2 times +1 plus 2 times -1. What is this? It is equal to 0. Right? So indeed, the oxidation numbers are correct. Okay, the oxidation numbers are correct. So guys, I hope now you see why we had a quiz where we asked, in fact it was a poll where we asked whether you think oxidation numbers are straightforward to calculate. All right? So for those that participated, I hope this answers your question. Okay. All right, now let's look at number 5. What is number 5? Number 5 is, okay, H2O. So number 5, it's H2O. I didn't underline any. So the question we're going to ask ourselves here is, when you look at this, what is the oxidation number of, but it's something that I think I should leave you guys to calculate this. All right? I should leave you guys to calculate this. This is straightforward to calculate, isn't it? It's straightforward to calculate. You know the oxidation number, right? You know the oxidation number. And I know it's very tempting to think this is supposed to be a peroxide. Guys, it is not a peroxide. Okay, it is not a peroxide. It's your normal oxygen atom. So maybe let me just do it. Hydrogen with a non-metal. What is the oxidation number? It is +1. Oxygen, this is not a peroxide. Remember, peroxide has a subscript 2. So what is the oxygen here? So the oxygen here, its oxidation number is -2. Okay? Its oxidation number is -2. Now check. Positive 2 times +1 plus -2. What is it equal to? It is equal to 0. Remember, the oxidation number here will be 2 hydrogens plus oxygen must be 0. Indeed, it became 0. Okay, do not confuse this, guys. It is not a peroxide. I know because you saw the power here, you think it must be a peroxide. This is a peroxide, right? This is a peroxide. Happy? All right. Now let's go to what is this? Number 5. What is number 6? Number 6 is KNO3, potassium nitrate. KNO3. KNO3. So KNO3, we are looking for that of this guy here. We are looking for that of this guy here. Now, even with this one, we have to be careful about it, but we're going to calculate it like normal. It'll be K plus X plus 3O will be 0. Where is potassium? It's in group 1 for sure. All right, it's in group 1. So let's go to check it out. Potassium is in group 1. Here is it. It's in group 1. So it is +1, isn't it? It is +1. So it is +1. Nitrogen, it's a known oxygen. Here, this oxygen, because it's bonded to all other elements, we just say its oxidation number is -2. Right? So what do we have here? We have 1 plus x minus 6 equals 0. So this is x minus 5 equals 0. Therefore, x equals +5. Okay, x equals +5. And this one, guys, if you were to do it like this, right? If you were to do it like this and say, right? If you were to do it like this and say, perhaps it should be like this, you are still gonna get oxidation number of nitrogen to be +5. Okay, you're still gonna get oxidation number of this guy to be +5. And I want to show you something. Where's nitrogen? Where's nitrogen? Nitrogen is in group, let's call it group 5. Okay, let's call it group 5, meaning it needs 3 electrons. It was still so this was it still gonna work? Yes, it was still gonna work. However, I advise that when it's like this, you either do it like this or even like this. But remember, at the end of the day, you must try to balance your charges. Okay, you must try to balance your charges, because I can imagine now, if I balance the charges, I'm saying this guy will be +1. So look at it, +1 plus 5 plus 3 into -2. What is this? This is 0. So indeed, the charges are balancing. Right? The charges are balancing. Happy? Perfect. Number 7. What was number 7? So number 7 is ALH3, ALH3, ALH3. Number 7, ALH3, and we are looking for the oxidation number of aluminium. Right? We are looking for the oxidation number of aluminium. So aluminium plus 3H equals 0, isn't it? Now, let's go check. Let's go check. What did we say about hydrogen? We said when combined with metals, it's -1. When combined with non-metals, it's +1. Now, aluminium, where is it? Where is aluminium? Aluminium, here is it. Is aluminium a metal or non-metal? It is a metal. Right? It is a metal. What is the rule when combined with, what is the rule when combined with metals? Oxidation number is negative. Okay, oxidation number is -1. Okay, oxidation number is -1. So we say X plus 3 into -1 equals 0. Okay, what is this? X minus 3 equals 0. So X equals plus 3. Okay, guys, I know you're looking at this and you're like, yay, what are you doing? This is supposed to be negative. Yeah, guys, there are rules. There are rules, okay? There are rules. There are rules. Okay, guys, it's important that you respect those rules. Okay, it's important that you respect those rules. So I'm still going to ask you, do you still think that oxidation numbers are straightforward to calculate? Not much, ne? Yes. So you see that they look easy to the eye, but there is a convention that you must apply. Okay, happy? Okay. Oh boy. All right, let's go. Let's go now. Number 8. Let's see what number 8 was. Number 8 was H2PO4. Let's go PO4 minus to be precise. H2PO4 minus, and we are underlining this guy here. All right, we are underlining this guy here. When I see them like this, I like saying, it means I can say it's H plus and PO4 2 minus. I like saying that, right? So let's see now. This hydrogen, it'll be plus 1, or by the way, it's 2 times. So it's 2 times plus 1, as you can see, plus phosphate, I do not know what you are, plus 4 oxygen, you will be -2 because you are not a peroxide. You will be -2. You are not even a superoxide. You will be -2, and this should be equal to -1. As you can see, the charge of this ion is -1. All right, the charge of this ion is -1. So what is this? This is 2 plus X minus 8 equals -1, isn't it? So what is this now? This is X equals -1 plus 8 minus 2. Therefore, this implies X equals plus 5. Right? X equals plus 5. Isn't it? X equals plus 5. Happy? Perfect. Let's see. Yes, it is. So we are good to go. So we are good to go. Where is phosphate? And we go phosphate. Here was it. Here was it. Plus 5. Cool. Plus 5. Okay. So this is how we do it. Okay. This is how we do it, guys. So I hope this is it, guys. I hope you now understand your oxidation numbers. Remember, if you would like to get in touch with us, you can visit our website www.ramtasolutions.co.za. And of course, please subscribe, share, and like the video. If you would like a tutor, please let us know. Send us an email or subscribe on our website, or you can even send us a WhatsApp. So this is it, guys. Bye-bye.